In question 4, we have a curve such that the dy dx is 2 minus 8 into 3x plus 4 to the power negative half. The point P moves along the curve in such a way that the x coordinate is increasing at a constant rate, which means that dx by dt is given as 0.3 units per second. We have to find the rate of change of y, so that means we have to find dy dt, which is an unknown. Now the formula relating dy dt and dx dt is that dy dt is equals to dy dx times dx dt. So we already have the value of dx dt. We need to find the value of dy dx when the curve crosses the x-axis. Now when the curve crosses the y-axis, this means that the value of x is 0. So taking x equals to 0, we'll substitute this value into the dy dx. So dy dx will be is equals to 2 minus 8 times 3 into 0 plus 4 to the power negative half. So this will become 2 minus 8 times 4 to the power minus half. So writing it as 2 minus 8 upon 4 to the power half. Square root of 4 is 2. So 8 upon 4, 8 upon 2 will be 4. So dy dx will be 2 minus 4, which is equals to minus 2. So the final value for dy by dt will be is equals to dy dx, which is minus 2 times dx by dt, which is 0.3. So the final answer is negative 0.6 units per second. In part 2, we have to find the equation of the curve. The curve is intersecting the y-axis where y equals to 4 upon 3. Now, if the curve is intersecting the y-axis, for part 2, we know that the value of x will be equals to 0. The value of y is 4 upon 3. To find the equation of the curve, we'll integrate the term in dy dx. So as dy dx is equals to 2 minus 8 times 3x to the power 3x plus 4 to the power minus half. We will write it as dy is equals to, and we'll put the integration sign on both of these functions. So this will become dy is equals to 2 minus 8 into 3x plus 4 to the power negative half dx. Integrating dy, we get y. Integrating 2, this will become a 2x minus, now to integrate this function, we will increase the power by half. So this will become minus half plus half. Minus half plus 1 is positive 1 upon 2. We will divide it by the new power, which is 1 upon 2, and also multiplied by the derivative of 3x plus 4. So the derivative of 3x plus 4 will be 3. So this will multiply in the denominator, and we'll add a c. So this is 8 divided by 3 upon 2, or we can make it 16 upon 3. So finally, to get the value of c, we will substitute the values of x and y as x0 and y4 upon 3. So in place of y, we can substitute 4 upon 3 is equals to 2 times x value 0 minus 8 times, so 3 times 0 will be a 0, plus 4 to the power 1 upon 2 upon 3 upon 2 plus c. So this will become c is equals to 4 upon 3 plus 8 times the square root of 4 is 2 divided by 3 upon 2. Substituting this value in the calculator, we'll get the value of c as c will be is equals to 12. So finally, we can write an equation as y is equals to 2x minus, we can bring the 2 in the numerator now. So this will become 16 into 3x plus 4 to the power half divided by 3 plus 12.